Kindly wait, I'll start the session. Okay. So once again, very good morning. If you have not joined in the Google Classroom yet, kindly remind me at the end. I'll share the Google Classroom code with you so that all the students could join in the Google Classroom and make use of the video recordings and the PPTs and the e-books uploaded in the Google Classroom. So in the previous classes, we were discussing about the basics of this blockchain. Yesterday we have talked about the history of blockchain and the introduction to the blockchain we have seen, right? So how the blockchain has came into existence, from what concept it has come. So before that, we have seen that for blockchain and the Bitcoin technology to come into existence, there are several other concepts that were already available. Based on those concepts, this Bitcoin and the blockchain technology has come. The e-cash systems, e-cash schemes, as well as the distributed systems. Based on these concepts, they have arrived at this Bitcoin as well as this blockchain technology. So today we will see some of the features of this blockchain, and also we'll also see a demo how this blockchain actually works. So there are several features of blockchain. We'll see one by one. The first one is distributed consensus. So already we have talked about both of these terms, right? A distributed system as well as the term consensus. So what is that meaning? It is the consensus is the agreement. Okay. So in a distributed system, that is in network with several number of nodes, when a transaction happens, it needs to be agreed by all the nodes, or at least majority of the nodes in the network. So when this distributed consensus feature is available, it means that a single version of truth, okay, or the all the nodes will have the same data, okay, it will all have the same data, and even without the requirement of a central authority. So though there is no central authority to monitor the transaction and those things, it is possible that all the nodes in the network themselves validate the transaction, and they share the transactions or the data that is present or updated throughout all the nodes, and they come to an agreement. Okay, so this is one of the feature of blockchain. So that helps that we can assure that all the nodes have the same data. Okay, and the next one is transaction verification. So this feature in blockchain technology means that, so once a transaction happens, it will be posted to all the nodes in the network. Okay, so once a transaction happens, it will be broadcasted to all the nodes in the network. So every node, or there are some mining nodes. We will study in detail about the mining nodes and all in the later modules. So the mining nodes, what they will do is they will validate the transaction. So once the validation is completed by one or more than one node in the network, that will be again propagated to all the nodes, telling that the transaction is validated. Okay, you can see in this picture. So you can see in the picture, someone requests a transaction, and so once a transaction is requested, transaction broadcasted to all the computer nodes. Okay, P2P, that is peer-to-peer computers. So here the network, it is all computing resources. So they are all computers. Okay, so it is broadcasted to different nodes and miners. Okay, so there are several mining nodes present in the network. We will see what is this concept of mining and all later, but it is something like they are validating, they are verifying the transaction by using the cryptographic concepts. Okay, so they once the miners verify that transaction that it is correct, they again pass on that information to all the blocks, and also that particular transaction will be included in a block. Okay, and then that block will also be added to the existing blockchain. So already yesterday we have seen the blockchain, it is a linked list. Okay, it is a data structure, or we can say that it is a linked list of blocks. So each block is nothing but a collection of transactions. Okay, so whenever a transaction happens, it is validated, and it will be added to the block. Okay, so once it is added, the transaction will be completed. Okay, so this transaction verification feature in blockchain helps us to verify that the data added in the blockchain is valid and it is correct, and also it cannot be easily changed. Okay, and another feature of this blockchain is that platforms for smart contracts. So this blockchain, it acts as a platform for smart contracts. So what is a smart contract? So smart contract, it is actually a program. Okay, it is they are simple programs. They are stored in the blockchain, and in that program or the code, it includes some conditions. Okay, for example, you may be a buyer, and you may be buying a property or land or something from another person. Okay, so you might have made some contracts, and we can say that there may be some conditions given in that thing. Okay, so when you make an agreement between buyer and a seller, there may be some conditions, or there may be some agreements you would have made. Okay, so these conditions, these predetermined conditions, are converted into code, and that is what we call it as a smart contract. So this code will get executed when that conditions get satisfied or met. Okay, so in that case, what happens, there is no need of, see, for example, if you are going to buy a land or a property, what will you do? It has to gone through several brokers, and you need to go and register it in office. So several things are several processes are there. Okay, but when we go with this kind of thing, there is no external party. Okay, there is no third party available, and it actually happens automatically. Okay, so when you do that smart contract, when you put it as a program or a code with the required preconditions, the when it is met, it automatically will execute based on when that particular condition is met. It triggers that coding to get executed. Okay, so automatically the property will be belonging to the other person. So okay, so it means that you are exchanging your property or selling your property to another person. So what is the precondition? See, for example, you're buying a land. Okay, you are having a land and you are selling it to another person. Okay, so let us take as A and B. Okay, A is selling the land to B. So now what is the preconditions? The A is selling the land, means he has to give all the required the documents relevant to that particular land to the party B. Okay, and what party B has to do? B has to transfer the amount that you have discussed to the party A. Okay, so this is the preconditions. So A has to send the documents relevant to the land to party B, and party B has to agree on to send the required amount of money for that land to party A. Okay, so now when this transaction is over, okay, when you send the documents relevant to the land to party B, and when the party B has sent the has transacted the money to party A. When this precondition is met, what happens? The land is now the land is sold. Okay, so now the property belongs to party B. Okay, so this will happen, and so this will be recorded as a transaction in the blockchain. So now party B becomes the owner of the land, and party A have received the amount, and also it has transferred the required documents to the party B. Okay, so the pre-programmed contract, the coding, it can be run on the blockchain platform. So once this transaction, the sending of document and receiving of money, this happens. Okay, the chain of the, so that is the triggering condition. So once this is over, then automatically the execution happens and the value will be transferred. Okay, so now the land will be owned by the party B. Okay, so such kind of things. So now you just think of normal procedure, how you buy a land and sell a land. Okay, so definitely you need some brokers to do all these things, and you need to register in an office. Okay, several things are available. So that is how this blockchain technology, it helps as a platform for running such smart contracts. And so you can see here, smart contracts are simply programs stored on a blockchain that run when predetermined conditions are met. They typically are used to automate the execution of an agreement, okay, so that all participants can be immediately certain of the outcome. So now when this program got executed, then immediately the document that is relevant to show that you are the owner of the land will be available with the party B, and the required money will also be available with the party A. Okay, so without any intermediaries involvement or time loss, this process can be executed. Okay, so that is the advantage of this smart contracts, and for doing that, blockchain acts as a platform. So though this is not available in all the networks, there are several blockchain networks available. So some of them are now updating to this smart contract. So Ethereum network, so and several other things are available now to do this. Okay. The next one is the another feature of this blockchain is that transferring value between peers. Okay, transferring value between the peers. So here it is again the same code, same kind of thing. So earlier we have talked about digital currency, right? So e-cash, digital currency we have talked about. And this token, what so here we are able to in blockchain we will be able to do the transfer of value in terms of tokens. Okay, so in terms of tokens we will be able to do the transfer. So what this token is that it is a digital asset. It may be a digital asset. So what this digital asset may be? It may be anything. Okay, it may be a document, or it may be a video, or it may be an image. You could see in the picture here. So it may be anything. Okay, so this token, it actually represents a set of rules encoded in the smart contract. Okay, so it is also connected with your smart contract. So now it is it is actually the digital asset that is going to be stored securely in the blockchain. Now so as we have discussed in the previous example of this smart contract, like transferring a or buying and selling a land. So here it is the so the document, as we said, the digital document has to be transferred, okay, to the other party, so that he will become the owner of the land, and the same way he has to transfer the money to the party A. So that is done via this tokens. So now this token is a digital asset. Okay. So instead of paperwork, okay. So usually you would have seen buying of a land or a house or something. So several even books of papers is used, okay, as an agreement or a sale deed, something. Okay, so instead of that, it is all a digital document, and it is a digital asset that is transferred and in the name of a token. Okay, so so in that way we'll be able to transfer the value. So it means that it is not simply transferring a document. It means that you're transferring that value for that land. Okay, so you're transferring the land to that particular party. So it is transferring value between the peers. So that is possible in the blockchain. And another thing is generating cryptocurrency. This also we have already discussed in the class. So I told you that the physical currency that we use now, right, the rupees or dollars or whatever it is. So the physical currency, it is maintained by a central authority. Okay, in our country, it is the Reserve Bank of India. It handles the currencies, right? So whenever in each year they will decide how much currency is needed, and they will print it, or if it is a coin they will manufacture it. So they will generate the currency, okay, and they will distribute it to the banks and to the people through various modes, okay, various transactions. So now here in the case of blockchain technology also, how the cryptocurrency is generated is that one way is a blockchain can generate the cryptocurrency as an incentive to its miners who validate the transactions, okay, and spend resources in order to secure the blockchain. So how here cryptocurrency is generated is that we have talked about the network and some of the mining nodes. Okay, so you have the you have a network where different nodes are available, and for each of these nodes the transactions were passed on. Okay, so once a transaction happens to all the nodes in the network, the transaction will be sent. Okay, so say for example, the transaction T is now passed to all the nodes, and there are some mining nodes or It depends. Okay, we will see later. So because for doing this mining process, it requires a lot of computing power. Okay, lot of computing power. So not all the nodes may be affordable to do that. Okay, so there may be some mining nodes in the network which could afford that computing facilities and power, and they will do the validation. Okay, so we will see how this validation is done, what is mining. So you need not bother about that now, but just understand that we are just verifying the transaction. Yes, this transaction has happened and it is correct. Just make a simple example, buying a coffee from a coffee shop. Okay, so person A has sent some amount to the coffee shop for buying a coffee. Okay, so some amount has been transferred between two individuals. So now this is a transaction. Now this transaction has to be verified, and it should be that what is the meaning of that? What is verified there? If you have 100 rupees earlier, and if you are spending 50 rupees for some purchase, then remaining 50 rupees will be with you, and the spent amount has to be with the other party. Okay, so now it has to be validated and verified by, because there is no central authority. If you are going through some bank or something, automatically we will know that the money has been detected from your account and it has been sent to the other account. There is some central authority that they will spend. You would have received messages from the bank, right, whenever you do some transaction. So this much amount of money has been debited from your account, or this much has been credited to your account. So you would have received some message, some central authority will be there. But now, since this blockchain is a decentralized network, okay, so there is these mining nodes are going to validate this transactions. Okay, what is done is right. Okay, so now for those mining nodes, we need to give some incentive. Okay, they need to have some incentive because they are using so much of computing resources to do that validation. Okay, so now as a part of an incentive to that to their work and for their effort, the cryptocurrencies are generated and given to them. Okay, so for example, bitcoins will be generated as an incentive for this mining node, and it will be now that will be owned by that particular mining node. Okay, so generating cryptocurrency is another concept of this particular feature of this blockchain. And the next one is smart property. Okay, smart property. So now the same thing actually we are talking about. It's all dealing with the same kind of things. Okay, again it is the digital asset. Okay, that is added to the blockchain, and it cannot be revoked by someone else. Okay, that means so whenever you are having your particular so this also we have discussed earlier, double spending. Okay, in the case of physical currency, there is not a possibility for double spending. If you have 100 rupees in your hand, and if you spend 100 rupees in a shop, then you are physically handing over that amount to that particular shop. Okay, so that means you will not be able to use that 100 rupees again to another shop. Okay, you cannot go to another shop and again you can duplicate a copy of that 100 rupees and you cannot spend. Okay, so that is not possible. But here in the case of digital currency, there is a high risk that you may be able to make a copy of that and you can do that. But now in blockchain, blockchain is the first thing, or Bitcoin is the first implementation where this double spending is avoided. Okay, so here the digital asset or the whatever the thing whatever may be. Okay, so whatever the digital asset that you are transferring here through blockchain, it cannot be claimed by anyone else, or it cannot be double spent by you yourself. Okay, so this is the main important property of this blockchain. Okay, and So the double spend problem was first solved in Bitcoin, and also in a blockchain, if you own it, no one else can claim it. Okay, if you own that particular asset, no one else can claim it unless you decide to transfer it to someone. Okay, so without your permission, it cannot be owned by anyone else, and also it cannot be double spent or double owned. Okay, you yourself cannot spend it twice, or you cannot own it twice. Okay. The next one is next feature of this blockchain is that it is a provider of security. Okay, so when we talk about security, the main thing is the how secure is your data is, and this blockchain technology, it ensures the integrity and availability of data. So this is what we were discussing about the thing that is lacking in the distributed system, right? In distributed system, we have seen that the theorem, right? CAP theorem we have seen. So what does the CAP theorem says? It is consistency, availability, and uh, fault tolerance, right? So now but here in blockchain, the availability is also there, and also integrity, or the consistency. Okay, so it ensures the integrity as well as the consistency of the availability as well as the consistency of the data. But in distributed system, it talks about the consistency of the data. So here what is the problem that here many because this blockchain is now applicable to various domains. Okay, it may be finance or it may be in law. Okay, so in various domains now blockchain is getting involved. But considering this financial institutions, they are actually hesitating to use this. Why? Because is that they need privacy and also the confidentiality of the transactions. But sometimes when transparency is given, okay, transparent means, so it should be it is visible, or it should be very transparent. Okay, as you know the meaning of transparent. So it should be available to all. Okay, the data should be available to all, and so on. But in the case of financial institutions, it is not possible. You cannot show the transactions to everyone, who has spent what to, who has sent money to whom. Okay, you cannot reveal the things to everyone. So such kind of financial things, they need privacy and also the confidentiality. Whereas so there are some other situations where confidentiality is not at all required. Okay, only they need to have a transparent system. So for example, in Bitcoin, there is no need of confidentiality. So, but there are several researches now going on, which also provides the confidentiality and also the privacy. Okay, so the more recent example is Zcash. You can just go and Google and find out what this Zcash is, and how confidentiality and privacy is provided there. Okay, and here and some other security is also available in this blockchain. One is non-repudiation. Okay, non-repudiation. So what is the meaning of this non-repudiation is that, see, sometimes what happens is that the sender or the receiver may disown that this transaction has not happened. Okay, this may happen in any process, right? Sometimes people may send email and say that no, I have not sent it. Someone else has misused my thing. Okay, misused my email address, and they have sent my thing. So this may happen anywhere. Okay, so that means the sender may disown what he has done, or the receiver may disown. Okay, so but now this when a transaction happens, both the sender as well as the receiver has to confirm and say that yes, this transaction has happened. Okay, they cannot disown that thing. Okay, the so non-repudiation is nothing but assurance that the sender of the information is provided with proof of delivery, and the recipient is provided with the proof of the sender's identity. So sender cannot say that, they cannot deny that this information has not processed by me. So as we have discussed now, the party A and B were agreeing to sell a land uh, uh, and to receive the money. Okay, so now after having done all the things, the sender cannot come and deny that I have not sold my land. It is somehow it has happened. He cannot say that. Okay, so both sender as well as the receiver has to accept that the information that has been processed or the transaction that has been happened is true. Okay, it has happened. So that is what called the non-repudiation. Okay, and so that is provided by this blockchain technology. And the next one is authentication. So this means it refers to systems that verify users to the resources found on the underlying technology of Bitcoin and other digital currency. So it means that whether this particular Bitcoin or the resource or the digital asset he has spent, it is whether it actually belongs to that particular person. Okay, so that can be easily verified here in blockchain technology. So see, in the case of physical currency, you see, when you pass on 100 rupees note, and so you give it to a shop owner. Okay, and the shop owner in turn, he give it to another person. Okay, for an exchange of coins or something. Okay, and then that person gives it to another person, it goes on. Okay, so this physical currency may travel around the country. Okay, it may travel around the current country, but after a few days you will never be able to identify who has first used that currency, or who is the owner of that currency. It is not at all possible. Okay, it is not at all possible. But in the case of this digital currency and this bitcoins, every currency, it will be labeled. Okay, so it is easily trackable. So from whom it has been passed on to another person. For example, initially Alice is having one Bitcoin. She transferred that coin to another shopkeeper, Bob. Okay, so now it is recorded. Okay, so this particular Bitcoin first initially was held by Alice. Now it is available with Bob, and then it will. Then if Bob is giving it to John, then that will be recorded. Okay, so you will be able to trace back the history of that particular coin, from where it has started and how it is passed on to different persons, and how it now where it is. Okay, all these can be verified using the blockchain technology. So that is what this authentication talks about. And the next important thing is immutability. I think we have discussed this earlier in the previous class also. So once you record a transaction into the blockchain, it cannot be changed. Okay, that is immutable property. So, but it means that it is not that it is not impossible. It is possible, but the cost involved is too high. Okay, it is an unaffordable amount of computing resource involved in doing that rolling back. Okay, so you can roll back to the you can do the changes, but it is unimaginable. Okay, so the cost involved in that is unimaginable. So that keeps the hackers, or keeps the malicious users from doing that. Okay, so in a much desirable case of Bitcoin, if a malicious user wants to alter the previous blocks, then it would require the computing proof of work. POW is proof of work again for all those blocks that have already been added to the blockchain. I'll show you a demo. I think you'll be able to see this demo page. You can see here there are some 5 blocks in this. Okay, let me go one by one. So first let me tell you what is available. Maybe final years you would have, you will understand this. Third year, since you have not studied cryptography yet, you may not understand that, but simply look into this demo. It is when we study about the cryptographic principles and the calculations of hash, you will be able to understand. See, in cryptography, for any message that you send, okay, so that will be converted into another form. Okay, so if you're just giving hello, how are you, then that message will not be sent to the other person in the same format. Okay, you're going to encrypt it. Okay, so there are several algorithms for that. Encryption algorithms are available. So you can see that if I am typing here, you just look into the values that are changing at the bottom row. Okay, the hash is shown here. Okay, some hash value is generated here. So as I keep on adding each letter, you can see how it is getting changed. Okay, so there is a hash value now generated for this text good morning. Okay, so now this particular thing has this hash. Okay, now even if I add only one letter to that, the entire hash value will change. Okay, the entire hash value will change. So you cannot even guess. Okay, you cannot even guess what would be that. Okay, so because so if for example, if only the last 4 digits were changing when I include one more letter, then it will be easily you can easily guess. Okay, but here it is not at all possible. For each letter that you are adding, it is keep on changing. Okay, the hash value. I'll post this in the Google Classroom, the PPT, so that you can also go to this particular, or even you can see this link here, and you can go and check with that. Okay, so the next, so this is how for each message that you are passing on, the hash value will be computed. So now we will see also what is a block. So you can see here it is just a demo. Okay, so most of the features, most of what actually present in block may not be available here, but what is required is here. Okay, so so this is one block. Okay, and there is some data already hidden there. Okay, so for that particular data, a hash value is here. Okay, and here you can see a value called nonce. Okay, nonce is that number that is used only once. Okay, number that can be used only once. So actually we I'm keep on telling about mining. Okay, the miners, mining nodes. So what is that is, so once a transaction is sent to all the nodes, the mining nodes will generate a nonce value. Okay, so for that particular data, there is only one such nonce value. So you can see that if I simply add one more extra one character, the hash value will change. Okay, you can see the hash value. So initially, so though the data part is empty here, it is designed such that already there is some other data for which this hash is generated. Now if I want to change something, the entire hash is changed and it will not validate with this nonce value. Okay, the nonce value that is available here is for the data that is already mined and it is validated. Okay, for that verified data, this nonce value has been generated. Now, if I try to change anything, then the hash value will be changing and it will not, it is not meeting the requirements of this particular nonce value. So what I have to do, then again I have to mine. Okay, again this mining process has to be done. So you can see that for the updation that has been done in this particular transaction, a different nonce value has been generated and a different hash value has been generated. I'll show in the next thing. So now we'll see a chain of blocks. Okay. So now you can see here there are some 5 blocks added to this blockchain. Okay. There are 5 blocks added to this blockchain. And you can see here this is block 1, 2, 3, and again we have 4 and 5 is there. So if the you can see here there is a column previous and another one is hash. So for the block 1 data there is a hash value. Okay, this is the current block's hash value, block 1's hash value. And well, let us keep that this is the genesis block. Genesis block is the first block in the blockchain. Okay, and so you see here the previous block, there is no block previous to this one, so that is all zeros. And you can see in the second block the previous value, okay, the hash value of block 1 and this will be same. Okay, so that means we have seen that how they are linked with each other. Okay, these are all blocks, they are linked to each other. Okay, how? Using the hash value of the previous block. Okay, and you can see that the block value of the hash value of block 2 is available here in the block 2's previous hash. So all these blocks are now linked together. Now if you are going to change even a small value in any of the block, all the other blocks it will be gone wrong. Okay, and for each of the block there is a nonce value generated. So this nonce value is generated by validating all the transactions present in this block. So if you are going to do any change in the transaction, then that will be reflected in all the blocks. Every block will go wrong. Okay, so then what you have to do is you have to if you really want to change, then you need to mine all the blocks again to get it right. Okay, it is mining. So so that is why, okay, some error is coming for me. So it is still mining. Okay, it is mined. So now still all the other blocks were in error. Okay, so you have to mine this block again because the hash value was based on the previous hash value. So now when this hash value changes, automatically here also it will affect. So like this, that is why it is so secure and it is immutable. It cannot be changed easily. This mining here, it is not a clicking of a button. Okay, it is a demo and we just click and we are getting the value, but in process it is not so. It is it involves huge computing resources and it is not affordable to do any change. Okay, so that is why this we can say that this blockchain is so secure and it is immutable also. Okay, and also it is unique, and we have already seen double spending is not applicable here. Okay, smart contracts already we have seen. So the remaining things we'll see in the next class. So now let me take the attendance. Kindly give the attendance fast. Do you understand this, ma'am?
Yes,
Can I
ma'am.
get some response?
Yes, ma'am.
Okay, kindly give the attendance quickly. Pragna, unmute your mic and give the, yeah. Neela Sumant, 38.
Present, ma'am.
Jomin Jose,
Present, ma'am.
Manoj Preetham,
Yes, ma'am.
Jerome Andrew. Jerome, are you there? Nelson Darius,
Yes, ma'am.
Gemini,
Present, ma'am.
Sheshandri,
Present, ma'am.
Annie Cruz,
Present, ma'am.
Venkata Mukesh,
Present, ma'am.
Naveen Kumar,
Yes, ma'am.
Satish Kumar,
Yes, ma'am.
Preetham, Jaladi Preetham,
Present,
1001,
ma'am.
Jeffrey Jabastin,
Present, ma'am.
Benzam Raj, Bensam Raj, Angeline Subagar,
Present, ma'am.
Ujjal,
Present, ma'am.
Laswita,
Present, ma'am.
Joel Sam,
Present, ma'am.
Steve Abraham.
Present, ma'am.
Yeah, Jeffrey, I'll give you the GCR code. Kindly wait. Steve Abraham present. Aditya,
Present, ma'am.
Bevin,
Present, ma'am.
Soumya,
Present, ma'am.
Adina Sneha,
Present, ma'am.
Joseph Rajan,
Present, ma'am.
Karen Beulah,
Present, ma'am.
Christo,
Present, ma'am.
Divina,
Present, ma'am.
Alex Kuriakos,
Present, ma'am.
Bharat,
Present, ma'am.
Ashish Kumar,
Present, ma'am.
Manuel Raja,
Present, ma'am.
Jabez Samuel,
Present, ma'am.
Sam Jonathan,
Present, ma'am.
Vigneshwar,
Present, ma'am.
Chinmuan Lal,
Yes, ma'am.
Letitia,
Present, ma'am.
Christina Sherin, Christina not present. Ashley John,
Present, ma'am.
Hayden Rex, present. Sriram,
Present, ma'am.
Jemima Elizabeth Paul,
Present, ma'am.
Arsha Anna Daniel,
Yes, ma'am.
Rajat Nair,
Present, ma'am.
Rishabh Nair,
Present, ma'am.
Manoj Abraham,
Present, ma'am.
Bibia Susan,
Present, ma'am.
GB Thomas,
Present, ma'am.
Selvam Abisha,
Yes, ma'am.
Nabilash,
Yes, ma'am.
Don Milton,
Yes, present.
Genovin,
Present, ma'am.
Darwin,
Present, ma'am.
Lamek,
Ma'am.
Lamek, Maria Santosh,
Yes, ma'am.
Sasidhar Reddy,
Present, ma'am.
Austin,
Present, ma'am.
Kambam
Present, ma'am.
Sanjay, Kevin Paulson,
Present, ma'am.
Sri Sai Rahul Reddy, Kavin,
Present, ma'am.
Johnson, Singham Shetty,
Present, ma'am.
Sai Srujan,
Present, ma'am. Present, ma'am.
Kavin present.
Yes, ma'am. Present, ma'am.
Okay, Sriram,
Present, ma'am.
okay, the absentees are 180, Your K 18 CS 180, 19 CS 1007. 180, where have you gone? Every day you are coming like this.
No.
So you will just switch on it and we'll go somewhere. Once the attendance is taken, you will come back.
No, ma'am.
Yesterday also you did the same thing. 1007, 1063, 1213. Okay, thank you, students. You can leave the class.
Ma'am, please
Yeah,
your
yes.
password.
Okay, 1 minute. See, I put it in the chat box, Jeffrey.
Thank you, ma'am. Ma'am, are you also taking optimization methodologies?
No, ma'am, no.
Okay, ma'am, thank you.